Well, student, now we are going to take up a new chapter in optics, and it is branch of optics, and it is wave optics. So far we have talked about geometrical optics, and we have seen that the basic consideration in geometrical optics is a rectilinear propagation of light, that is, light travels in straight line. Now this chapter, wave optics, is important from the point of view of IIT JEE, IIEEE and other entrance examination. We had questions frequently from this topic, and the questions which have been set from last many years, they are sometimes tricky as well. So we have to understand this topic in very good detail. In fact, as far as IIT JEE is concerned, we need to have a thorough understanding of each and every concept. So this topic is not without exception. Now here in this topic, that is wave optics, we are going to talk about three wave phenomena, that is interference, diffraction, polarization. Now in IIT JEE syllabus we have interference only, so we'll be restricting ourselves to interference. Now let's slowly move into the fundamentals of wave optics. We said in the beginning, geometrical optics is the limiting case of wave optics. That is, wave optics is a general situation. Now in situation where the size of obstacle or opening is not comparable to wavelength of light, we can ignore wave nature of light and we can assume light is travelling in straight line. That was the basic consideration in geometrical optics. Now in wave optics, the fundamental consideration is that we assume light energy is propagated in the form of waves. That is, waves carry energy and momentum. So light propagates in the form of waves. That will be the foundation and a basic consideration for this chapter. Now, as we said in the beginning also, there will be situations when we will have a conflict between geometrical optics and wave optics. So in situation of conflict, it is always the wave optics consideration which will dominate the situation. We'll have one interesting example where we'll be using the concept of optical equivalence, and we'll see that the consideration from geometrical optics and wave optics are different. And finally, wave optics will have say in such conflicting situations. So students, in wave optics, the basic consideration is wave nature of light. That is, we assume light propagates in the form of waves. We also know light is an electromagnetic wave and it has wavelength ranging from 300 nanometer to 700 nanometer. Now if we just examine the wavelength of light, it is very small, because we know that 1 nanometer is 10 to the power minus 9 meter. And so if we just try to imagine the size of wavelength, so we find that compared to the day-to-day objects we deal in our life, this wavelength is very, very small. That's why to encounter wave phenomena in light, we have to go for special arrangements. We have to look for special situation where we ensure the size of obstacle or the opening is comparable to wavelength of light. Now this is a very, very interesting chapters, as there are many interesting applications of wave phenomena which we are going to study. The very first phenomena we are going to take up is interference. Let's understand what is interference all about. Now this phenomenon of interference is nothing but when we have two waves of same frequency traveling in same direction or nearly same direction, they meet each other, resulting in redistribution of energy in the region of superposition. We call it interference. I repeat, students, that is the phenomenon of redistribution of energy when two waves traveling in same direction or nearly same direction meet each other is known as interference. So basically, interference is a phenomenon of redistribution of energy in the region of superposition. Now we can see very clearly, and this phenomenon of interference is basically based on two principles. The very first principle is law of conservation of energy. All of us are familiar with law of conservation of energy. Now according to this law of conservation of energy, we know that energy can neither be created, cannot be destroyed, but it can be transformed from one form to another form. The phenomenon of interference is based on conservation of energy. The second principle which is involved in the phenomenon of interference is principle of superposition of waves. Now this is very important. Let's understand what is principle of superposition all about. Now this principle of superposition of waves simply states the waves, irrespective of the nature, whether they are mechanical or non-mechanical, while traveling in the medium behave independent of each other. Now what does it mean? It simply means waves retain their individuality while traveling in any medium. I repeat, student, the principle of superposition of waves